Section 6.6, I'm going to split up into two different videos. The first one I'm going to show how to solve log equations, and the second one I'm going to show how to solve exponential equations. So, if we start with the exponential form of equation conversion to log form, we can use that to help us solve different equations. So, let's first start with a log equation. Now, we cannot make this conversion unless it is a single log. So we may have to use log properties to write them as a single log, which I talked about in 6.5. So if I go to solve this guy and convert it to exponential form, I get that, which is 8 equals 1 minus 2x. And if we solve this, I get 7 equals negative 2x, or x equals negative 7 over 2. Now, something very important whenever we are solving log equations is we need to check our answer, because that x is inside of a log, and we cannot take log of 0 or negatives. We talked about that a couple sections ago. So you always need to check your answer to make sure we are not taking log of a negative or 0. So if I plug that in, our answer, you see that that part inside there simplifies to 1 plus 7, and then that's log of positive 8, which is perfectly okay. We can take log of positive 8. So that answer is fine. So we always need to check our answers. Another property we covered in the last section that will help us is we know that if m equals n, we can take log of both sides. If we take log of one side of the equation, we have to do it to the other side. Also, if log base a of m equals log base a of n, then we know that m has to be equal to n. Both of these we can use for helping us solve logs. So let's say I have something like this. 2 log base 5 of x equals log base 5 of 9. Now, I cannot use this rule just yet because of this 2. But looking at my log properties, any coefficient I can write as a exponential on the argument inside the log. Then in that case, I can use this above property and say that x squared equals 9. And if I solve that, I get plus or minus 3. So x equals 3, x equals negative 3. Now, I need to check my answer in the original thing. So if I take let's say I take positive 3 and plug it in right here, that's fine. But if I take negative 3 and plug it in for that x, I would be taking log of a negative 3. So I cannot use that because that would be taking log of a negative. We cannot do that. So we throw that answer out. Okay? So let's do some more examples, and always remember to do that. Let's say I have log base 5 of x plus 6 plus log base 5 of x plus 2 equals 1. One of my log properties said if I have the same base and the two logs are added, I can multiply the arguments. Now that it's a single log, I can rewrite this guy as an exponential. 5 to the first power equals x plus 6 times x plus 2. This is 5. Multiply this out, x squared plus 2x plus 6x plus 12. And if I subtract 5 from both sides, this 2x and 6x becomes 8x, and then 12 minus 5 is 7. That guy factors into x plus 7, x plus 1. So if I set each of those guys equal to 0, I get negative 7 and negative 1. Now check your answers. Okay? If I plug in negative 7 up into this guy right here, I would have negative 7 plus 6, that would be negative 1. So we'd be taking log of negative 1. And it's even more on this side. So I have to throw it out. But if I put in negative 1, that's going to be positive 5. That's going to be positive 1. That's okay. So that's my only solution. Okay, I hope that makes sense. Let's do one more log example. Let's say I have the natural log of x equals the natural log of x plus 6 minus the natural log of x minus 4. Now, if I go back up and look at this rule right here, I cannot do this just yet because I have two different logs here. So I need to combine them into one log, and since there's a minus sign, I take the first one divided by the second one. Then I can imply that the arguments have to be equal to each other. Then I can solve this guy. Multiply both sides by the denominator to get rid of the fraction. X squared minus 4x equals x plus 6. Put everything on the same side. X squared minus 5x minus 6 equals 0. So it's going to be x minus 6, x plus 1 equal to 0. Set each of those equal to 0. We get 6 and negative 1. Check them back up into the original equation. This guy. We're good. Positive, positive, positive. So that answer works. This guy, right away, we're going to be taking log of a negative. So we throw it out. So the only solution is x equal to 6. Okay? So I'm going to make another video for solving exponentials because we're going to need the calculator for those.